Hello and welcome back to The Farmer Was Replaced. So last time we got up to this 4x4 grid and we have trees planting on the checkerboard patterns and we were running a little low on carrots. So we ran carrots everywhere else. You see we have some logic kind of commented out here at the bottom. And this is just to split things up between carrots and bushes. And again, if you want to see the code, there is a code repository where we're tracking all these changes that is linked in the description. So please, by all means, if you want to check out the individual parts and specific progress to a part, go ahead and check out that repository. Up next, I think we're going to go ahead and check our unlock tree. We can double the productivity of our carrots. I think that sounds pretty good. Double the cost and double the yield, I suppose, of our carrots. Okay, so we've updated our carrots. We don't need much more for trees. I guess we can. Might as well. Can't hurt. We can go ahead and get more speed. I think now is a good time to get census. We're going to go ahead and do that. That's going to give us a new thing of documentation to read. Where is it? Okay, so we need variables to get to functions. And I think what I'd really like to do this part is start defining some functions and take some of our logic, break it out into component parts. Well, I guess we'll just go ahead and unlock variables because that'll get us one step closer to functions. Back to our unlocks, and we can immediately get functions. I think that's about all we're going to be able to get for now. So let's see what we need to get imports. For import, we're going to need 80 carrots. Honestly, simple enough. Let's go back to our game, and then we're going to do our trees and carrots. That'll give us plenty of wood, plenty of carrots. And if we start to get concerned about hay, then we'll do that. Yeah, we're not going to change any of the code until we actually have the stuff unlocked to do what we want to do. If we start breaking all this out into functions and then we get imports, we're still going to go back in and change everything. So as you can see with our new speed unlock, we're going a decent amount faster here. So it should not be too long. Let's go ahead and just open up our unlock panel, and we are 1 carrot away. There we go. We can unlock our imports. So we'll go ahead and do that. And now we can take a little bit of a pause. So this is where things are going to start to change. And honestly, this is probably going to be cut down because there's a fair bit that's going to happen. And this is not the most maybe visually interesting part. But we're going to do this plus button to give us a couple of new modules. First off, we're going to do traversal. I don't know, I could call this traversal, but I think honestly what this is going to be is this is going to be a farm plot. For now, we're going to call this plot. Because this is going to handle anything to do with kind of our plot of land here, or 4x4, eventually 6x6, all that stuff. And this will have maybe a little bit more than traversal eventually. So I don't want to make it too overly specific. I also don't want to do a crazy amount of modules. Okay, so anyway, we have our plot, and we're going to go ahead and do another farming. We may very well rename this in the future, but the actual core functions of it should stay pretty much the same. And then we're going to do routines. I think routines is one of the things that we're going to kind of redefine over time. So maybe I'll actually call this subroutines. Let's go ahead and in our main, basically in our plot, this is going to be a function. We're going to take this loop over the X, loop over the Y. We're going to make that a function as traverse the plot. This is going to take a subroutine, but before I name it subroutine, I'm going to call it a callable. So the idea here is we're actually going to pass in a function. No, actually, I'm just going to call it a subroutine right away. Do I actually dislike the name subroutine? What I will say is we may very well change the name of subroutines. Okay, let's do this. Action. I like this better. We're going to call this an action instead of a subroutine. And here in subroutines, we're going to call this actions. And I think this just better describes what we're doing, at least for now. So effectively what we're doing is we're saying in our traverse plot for every cell in the X and Y, we're basically going to go to each cell and we're going to perform the action that's given. And this is a function. So let's start with defining a tree grid. And this is going to kind of be, what we've done here. I'm actually going to rename it to trees and carrots. So what we're going to do now is we're going to kind of take this logic that we've been doing and we're going to apply it to an action, right? So we're going to assume that we're starting this function on some cell of our plot, and we need to determine if we're on one of our checkerboard spots or if we're planting a carrot. Unlike before where we had our X and Y as a loop, we're going to use sensors. So now that we have variables, basically what we're going to do is we're going to check our X position X, or Y position, get position Y. And we're going to see if x plus y modulus 2 equals 1, that we're on our grid spot. So we're going to plant entities dot tree. else plant. And I've been typing this off the screen, so just a moment. Okay, so we're back to our main screen. Apologies, I wanted to clean up some of the windows here. Okay, so we have our same if x plus y modulus 2 is equal to 1. We're going to plant a tree, else we're going to plant a carrot. The other piece, we're going to start with our if can harvest. Oops, wow, that's not how that works at all. If can harvest. All right, awesome. So, new problem, our soil. We can very well do the same thing where we'll start this by tilling everything, but I think there's a better way, especially now that we have senses. We don't have to rewrite that setup every single time. Now that we have senses, again, trees can go on any soil type, so we don't actually care. If get ground type is equal to grounds.soil. Oh, hang on, apologies. Not equal to. Okay, so now we're using senses to kind of skip that setup. So if we're on a tree space, our ground type does not actually matter. Else, we're going to check if our ground type is not the ground type that we would like, and we're going to till it. For now, this farming thing is just going to be empty, so I'm actually going to move it over here. That's more of a for later thing. And it's not going to like something about this entities.carrots. Okay, we do have one other issue, and I apologize if you've been looking at it for a minute. We are not saving these as x and y anymore. It's x position and y position. So if our x position plus our y position modulus 2 is equal to 1, plant. Else, check the ground type until if we need to, and then plant a carrot. Well, obviously we can't just run this, because this is only going to run for one cell, so let's go back to our main. And we have our plot here. Oh, entities.carrot, my apologies. Okay, so now in our plot function, or our plot module and our traverse plot function, I see that this action is what's going to run on every single cell. We're going to go into our main, and like we mentioned before, we've done all of our setup. We're still going to clear at the beginning. It'll kind of delete some carrots and delete some resources, but it's fine. And we've replaced all of this by now. So while true, we're going to call, actually, correction. We're going to start by importing, import plot, and then we're going to import actions. So what this is going to do is basically just going to tell this main module, hey, you're going to need to use code from this plot module, and you're going to need to use code from this actions module. And so now while true, we're going to call plot.traverse plot. And then here's where we're going to get into that idea of an action or a callable being passed. We're going to pass in trees and carrots, but we're not going to add open and close parentheses to the end of it. So we'll pass this plot.traverse plot, and we're going to give it this trees and carrots. Actually need to give it the actions, tell it which module it's coming from. Actions.trees and carrots as a function. And so now we're going to go to every single cell on this plot, perform that action, and then move on to the next cell. And let's give this a shot and see if we run. Okay, I believe that should have fixed it. I guess I might have just had a little typo here in traverse plot. And there we are. So this is the idea of being able to pass a function in for the next function to use. And it's a great way to avoid a lot of if statements or kind of a lot of messy code. And really break things out and kind of compartmentalize them. So now if we take a look at our next planned unlock here. Actually, let's go ahead and get watering. I think that'll play really well into the next piece of cleanup I want to do. Let's go ahead and minimize some of these. Now we're going to go ahead and stop this. So a tank holds 0.25 water, and we can call use items.water to use 1 tank of water on the specific coordinate below us. And a cell can be watered anywhere from 0 to 1. We'll go ahead and close this out, and we're going to start getting into this farming piece. So farming is going to handle a bunch of planting actions, and for now, I think we'll probably change this later. Let's say plant, till, water. So we're going to create a function that's going to handle the planting, tilling of the soil if needed, and watering if it's a crop that we want to water. And since we're not going to accumulate water too quickly with just this first unlock, I think we're only going to water trees. That being said, we have about 1.3 thousand wood, so I think we're doing just fine on wood. Okay, so if we're thinking of a plant, till, and water, well, there's a little bit of information that we're going to need here. Entity we want to plant. That should not be capital E. Entity. So what entity do we want to plant? The water min. This is maybe not my best variable name. We're going to give this one a default value of 0.25. So we have a few variables that we've kind of built in this plant, till, and water function. We have the entity that we want to plant. We have this kind of threshold value of when our water for that cell is below this value, begin watering. And then we have the amount that we want to water to. I'm actually going to change this to be 0.7 instead of 0.75 because we will lose potentially just a touch of water and be like a 0.74 or something like that. And then it'll end up watering it to just about 100%, which is not quite what we're after here. So anything below 0.25, we're going to water. We're going to water it until it's greater than or equal to 0.7. There's one more check we're going to add here so it only waters on trees. Actually, maybe a better idea. Should water is going to be another variable. By default, we're going to make it false. So we have an entity that we're planting. We have a decision as to whether or not we should water it, the value at which we should start watering it, and how much we should water. A couple of things. We can get ourselves into some weird trouble here. If we're trying to water something over 100%, we're never going to get there. We're just going to use all of our water barrels, and that's going to be the end of it. So if water 2 is greater than 1, we're going to override it to 1. And I think water below, same thing. We definitely don't want this to be 1. Greater than or equal to 1. We don't even want it to be 1. Oh, sorry. This is, yeah, water below. Equals, we're going to default it to 0.7. Okay, so we've tidied up our watering stuff. Next, we're going to check for soil type. For now, carrots are the only things that need to be in soil, and we don't have lists or anything. Again, we could unlock them decently soon. I'm honestly not too worried about them, at least not for a minute until we get to pumpkins. So we're going to say if get entity type. So if our entity type is carrots, that means we need to have, that means it should be soil. And actually what I'm going to do, desired ground equals ground stop. Okay. So by default, we're going to assume that we want grassland. In theory, this should probably be the opposite, but the grassland's kind of like the default of the game, so I'll start here for now. Okay, so we have our desired ground, which is going to track what ground type we should have for the entity we've been given. We have our get entity type, and we're going to check if that's carrots, because carrots are the only ones where our desired ground is actually going to be soil. Grounds.soil. So we have our ground type, desired ground, we've tilled. Now we'll go ahead and plant entities dot, oh, sorry, that we don't need to do that. We have our entity passed in. We plant our entity. I'm going to go ahead and actually return this because planting will give us a true or false if it actually successfully plants. We're not using it out of the plant function, and we probably won't use it from the plant till and water, but might as well have it. Actually, I dislike this. So what I'm going to do is a plant status equals plant entity. Instead of returning the plant, we're actually just going to store it because we still need to water, and watering first is a kind of a waste of time. We're not letting anything grow while we're watering it. So we have our plant status. We'll go ahead and return it. And now we're going to handle the watering. So if should water, and if get water is less than water below, while get water is less than, and while it's less than water 2, use item items.water. I believe that's how that works. Okay, so we've kind of changed. Apologies. I don't know why I keep writing entities.carrots. That should be. And we have plenty of extra spacing here. Maybe we'll move this up. This comment is kind of unnecessary. Stepping back over, we have plant, till, and water. We'll validate and verify the inputs we've gotten to water below and water 2, just in case they're out of bounds. This is more just helping us. Desired ground, we're going to check that. If it's a carrot, we want soil, and eventually we'll expand this to other crops. We're going to till if we need to, and then we're going to plant our entity and capture the status, like capture the result of that plant attempt. If we should water from our parameter here, this is a bad use of 2 if statements, and get water is less than water below. Then we're going to enter a while loop, And we'll say while our water level is less than our water 2 level, we're going to go ahead and use items.water. I'm also going to say less than equal to here, just in case this gets set at 1. Yeah, I would rather say you are allowed to water to 100%. Okay, so that's going to be our farming function. Now we have to plug that into our main function here. Go ahead and bring these side by side. Plot.traverse actions, trees, and carrots. So it's going to be within our actions module. We don't actually need to bring this into the main module. Within our actions module here is where we're going to use this farming piece. So actions should import farming. And instead of calling plant, I'm going to call farming dot plant, till, and water. Now our entity here is going to be entities.tree. Should water is going to be true. Water below water 2, I think we're just going to leave as they are. Similarly, we're going to do plant, till, and water. Sorry, farming.plant, till, and water here. And if you see the amount of water barrels we have, you can see just how much I've just been taking my time through this whole thing. So plant, till, and water entities dot carrot. And then the default here is that it won't try to water the carrots. Although granted, I could water them and get that water down a bit. So actually, let's go ahead and do that. And go ahead and water them. Okay, yeah, no, I think we're good. Now we've gotten up to 91 barrels of water while I've just been talking and doing random stuff. So we're going to clean up our modules, move them all over. We're going to go to our main, and our main is super simple again, right? It's still just these same 2 lines. All of our changes have been in these little kind of helper modules. Ooh, we have something very interesting happening here. I think there's been a till call where we don't want one. Ah, here we go. So we'll notice that we've called this till function a little too much for these carrots. Farming the plant, till, and water, surprisingly, actually should be seeing certain things here. I'm not sure why it tried to do it again, but we had an extra call to till. So let's also just go ahead, now that we've taken that out, collapse our main function. For some reason, some things seem to snap, some things don't. Ah, here we go. Here's a small problem. We called get entity type instead of entity. This should be the entity that we are attempting to plant, not the plant that's under us. So if we are attempting to plant a carrot, we should be grounds.soil. All right, I think that should be good. Move back out here. We'll go ahead and collapse our things. Okay, now we should be good to run again. There we are, and now we're using up some of our water barrels, using them reasonably quickly, actually. And we have our carrot, and we have our tree grid. All right, I'm pretty happy with that. Okay, so here's a fun little cut. Technical difficulties. Turns out OBS was not recording, so there's some ground to kind of recover here, but not much has changed. So if I go to the unlocks piece, in one you'll notice some water has accumulated in carrots, and hay is still kind of low, but it's not super low. Maybe a new unlock. We got lists. We haven't really used them yet. Obviously, we have pumpkins unlocked. I think that was already done. Other than that, not too much. Okay, so after the kind of weird cut, we're going to come back and retrace the steps from the lost bit here. So the main goal here is to start building towards pumpkins. And to do that, we're going to build 2 new actions. We're going to do one, which is kind of this first pass for pumpkins, where we're going to, I'm just going to define these as like shells, and then we'll come back and we'll fill them out. So our first pass is going to just be plant pumpkins. For now, we'll just have this pass. And then our next one is going to be check and replant pumpkins. And the same thing, we're just going to have that pass for now. These are just the 2 different things that we're going to write. And then we're going to change how our traverse works. So up until now, we've been calling an action, and we don't really care what the result is. Like, we kind of know where everything is, what everything's doing. We actually want to gather a result off of each action, an optional one at that. So if the action doesn't return anything, it'll just return none, and then that result will store a value of none. Right, so we'll take result equals action. So if this callable sends something back, it'll get saved into result. We'll check if result. Then I forgot to delete this result list. We'll have result list dot append result. Where we haven't set any requirements on what that result is. It could be a Boolean, it can be a tuple, it can be kind of anything we want it to be. So with our updated traverse plot, we now return a list of our results, which again was already there. I forgot to delete it, but we've made a list of results. We'll check if our action function gave us anything back. If it did, we'll add it to our list of results. And then at the end of our navigating the plot, we'll return the results list. Eventually, as we get a little bit further with pumpkins, we're going to have something that can take a list of coordinates, go check all of them, plant pumpkins in them, and give us something back, which is very different from this looping over the entire range. But as a step one, we're just going to stick with our tried and true traverse method to avoid writing too much code in a single step. So we have our results list coming out of our traverse plot, and now we'll set up our plant pumpkins. Since we're only planting, we're probably not going to be able to check for dead pumpkins on our first iteration. So we're just going to leave ourselves a note here as a comment. First pass for pumpkins. This doesn't return anything. Alternatively, we could do a route where we return every point. Quite simply, most of what we're doing here is farming.plant till and water. Entities.pumpkin and true. And also don't mind the sheer amount of water we have. We stocked up on water when undergoing technical difficulties. So again, my apologies. I am trying to keep these resources somewhat in reasonable boundaries. Okay, so planting pumpkins, all we're really doing is plant and till, and then we'll go ahead and just specify the return none. So this pass should plant a pumpkin. Result should be none, which will evaluate to false, and so we will not put anything in the results list. And so at the end, this result list should be empty. Next, when we're going to check and replant, this is where we start caring about status, the actual status a little bit. So I think parts of this could probably belong in farming, but for now, I'm going to put it in this check and replant pumpkins. So first off, we want to check and see if we're over a dead pumpkin. There's one other thing, but we'll get to that kind of after we write the beginning here. So we'll do if get entity type equals entities.dead pumpkin. And shout out to the autocomplete for helping with the capitalization. So if we're over a dead pumpkin, we want to call our farming.plant till and water with entities.pumpkin. And we'll go ahead and check the water value as well and rewater if we need to. So we'll pass it the true for the should water, and we'll leave all the default, thresholds in there. Up next, so if we've found a dead pumpkin, we've replanted it, then, actually, let me check the document. There might be a better way to do this. It spends the cost of the specified entity and plants it under the drone. If it fails if you can't afford the plant, the ground type is wrong, or there's already a plant there. So instead of checking the entity, you want to see just if this planting function, which remember returns the status given from the plant. If we have planted something, right, we'll try to plant on everything. If we end up planting something, that means it's an empty space or a dead pumpkin. Now we'll return a tuple with our get position x and then our get position y. And we should have tuples as of a minute ago. I think if I check our unlock tree, we either get them here with senses or we get them here with lists. Either way, we definitely have them. Okay, so if we haven't planted anything, we'll just return none. Okay, error. There must be a colon. Oh, we have an if statement without a colon. If we successfully plant a pumpkin, that means either nothing was there or we have a dead pumpkin there. And then if we've planted something, or if we found a dead pumpkin, we're going to return the x and y coordinates. Otherwise, we're going to return none. And so if we look at this in our traverse plot, we'll take a look. So we'll call the action. If we don't plant anything, we'll get none, which should show up as false. In this if check, if we do plant something, it'll show up as true, and we'll append a tuple of our x and y coordinate to the list. We'll move east, and we'll move, we'll continue down the loop, and then we'll return the full list of any coordinates where we found a dead pumpkin. And I'm just going to add a comment here to kind of describe what we're doing. You know what? Actually, thinking something here. Since we are returning this whole list, and again, we are sticking with traverse plot for now, I think it would be best if, we're starting from here. Fraction. I think this plant and then this check and replant is not useful. There's actually a really easy way around doing point-to-point navigation instead of just traversing the grid if our list of points is the full grid. So we'll get to that in a moment. So we're just going to call this pumpkins. So we've gone from 2 functions down to 1, and we're going to try to plant everywhere. So all we need to do now, comment this out, is we're going to do, I guess there's 2 ways we could technically do this. We can put the call to our traverse plot in the while loop, which would technically give us a list back. So we can say, like, while there's values in the list that gets passed back. I have a small issue with it because it puts the actual logic that we're doing here within the loop condition, and it's a little messy if you're trying to read it, or it's not as self-documenting as maybe I'd like it to be. So I'm going to do a loop check variable. We're going to start it as true. So we'll do a while loop check. So we're saying, hey, so by default, start the loop. While loop check, we're going to do planted chords equals, this will be plot dot traverse plot with actions dot pumpkins. So we're going to call our handy dandy traverse plot, give it our pumpkins action, and then every time this runs, we're going to get a list of coordinates in the planted chords. Now, I'll add a little to do so we don't forget to check if list of coordinates is full grid. This will be helpful for when we create the follow-up for pumpkins, where we'll just go point to point. Just if there's 2 pumpkins that we need to tidy up, no point in traversing the full grid. But again, step 1, we're not going to worry about that. Say evaluate. Yeah, so loop check will equal the Boolean evaluation of this planted chords list. And here we'll just say else. Bring out of the loop. So this while loop will handle planting everything. Once everything's planted, and we know that traverse plot is going to dump us back at the origin when it completes, we can simply call harvest. Now again, remember, there are some issues here. There are some cases where this goes maybe not quite to plan. One other thing to note is that we need tilled soil for pumpkins, which means it's carrots and pumpkins, which are going to be on that tilled soil check. Let's go to farming. And now that we have lists, we can say if entity is in entities.carrot or entities.pumpkin. So if it's in one of our 2, we'll change our desired ground to soil. Actually, there's a small problem here of, as we get to the last couple things where we're planting a pumpkin, and we only have like 1 or 2 spots left that need a new pumpkin, like only 1 dead pumpkin to fix. We're quite likely to come back to that pumpkin before it's finished growing or before it's died. So what we want to do is add a little delay, or like a little sleep. And so while neither of the following are true, can harvest or get entity type equals, actually, instead of get entity type equals, we're going to say in, and then this will be entities dot none, entities dot dead pumpkin. Because remember, can harvest will return false on a dead pumpkin. And then what we'll do a flip. And this should be a function call. And I think that should be that. So I think we should be good to go, except entities.none doesn't exist. For some reason, I thought this did exist. Right? It's not entities.none. It's just none. Let's give this a run and let's see how it works. And there's our first dead pumpkin. Everything's getting watered, so it's growing nice and quick. And honestly, with all this water, we might not actually have ever needed to worry about, waiting for something to be harvestable. Ooh, and we have an error. Bool has never been defined. Okay, so that kind of throws a small monkey wrench in the plan here. So we'll have to do if len. Oh, hang on. Better option. So instead of doing this, like trying to assign it to a bool, what we'll do is loop check equals. The loop check will be true if the length of the planted coordinates list is equal to 0, which means I should make it not equal to 0. Let's try it. And we have our first few dead pumpkins. Here's where we erred before. It is still watering even when there's not a dead pumpkin. Fascinating. It went over that a few more times than I thought maybe it needed to. Okay, that looks better. I don't know why I did the extras the first time. There's the check. Okay, cool. Maybe just because I had to replace one of the things early, so it looked like it did an extra full check, but it didn't actually do it. Okay, so that's a decent first pass at pumpkins. I think this is maybe a good stopping point, and then maybe at the next part, we'll improve our algorithm. We'll do some better traversal. We'll go point to point and do like distance between points. Maybe we'll add some thresholds to make sure we can afford to do a full grid of pumpkins. Maybe we'll start on the next thing. Maybe we'll start doing some sunflowers. All right, so we'll go ahead and call that the end of part 2. I'm going to go ahead and commit the changes for part 2 into the Git repository. And remember, check the link in the description if you want to check out that repository. It should be on GitHub. It may also be on Codeberg. Link or links in the description. And yeah, if you have any feedback, please let me know. If you have anything you want to see me try, please, by all means, open to feedback, open to recommendations. And I'll see you in the next one.